The Mirage F1 is a supersonic fighter manufactured by the French Dassault Aviation. Designed from 1964 as a private venture to be a successor to the Mirage 3 and 5, it used the fuselage of the Mirage 3 mated to a shoulder-mounted swept wing, instead of the delta wing of the earlier aircraft. Although it has a smaller wingspan than the Mirage 3, the Mirage F1 proved to be superior to its predecessor, carrying more fuel while possessing a shorter takeoff run and superior maneuverability. The first prototype flew on December 1966 and the French Air Force placed an order on May 1967. The first production deliveries were on May 1973, and the production run until 1992, with a total of 720 aircraft built. On this mission, we will learn how to do a cold start on the Mirage F1 CE, following the procedure of the real aircraft, adapted for DCS. The cold start procedure includes the following sections: after entering cabin, cabin checks, which are optional, engine start, after start checks, the approximate mission time is 30 minutes, press spacebar to begin. You can adjust the sound volume produced by the background air traffic, by moving the in-cockpit sound slider on the DCS options audio screen, which you can access by pressing the escape key. This instructor's volume level can be adjusted with the helmet sound slider. Also, you can press spacebar to skip long voiceovers. By default, this training mission follows the full cold start checklist of the Mirage F1, including all systems checks. However, you can choose to omit all non-essential steps if you prefer just to learn the basics of this cold start. Press backspace if you prefer to omit all checks, or press spacebar if you want to learn the whole procedure. When it's dark, you can turn on the flashlight by pressing left Alt plus L. Try it now. The radar hood can be removed while on the ground and with the canopy open. Just press on the latch that it's directly above it. Do it now, as the hood prevents you from reaching some of the radar controls. To cut down on the external noise, close the canopy to its full down position by clicking on its handles or by pressing left Ctrl plus C. If you want, you can open the canopy to its intermediate position by clicking on its small top strut, followed by a click on either canopy handle. The mirrors can be turned out of the way by clicking on either one of them. Press M to deactivate their image, gaining a bit of. Remove the ejection seat safety pin. The safety pin prevents an accidental ejection when the airplane is on the ground. You remove it by left-clicking on it and dragging towards the front of the aircraft. You can also use the mouse wheel. The Mirage is equipped with a Martin Baker ERM6 ejection seat, provided with a face-blind firing handle above the pilot's head, and an alternative firing handle between his feet. Parking brake. Check it is set, its handle should be vertical and out. The Mirage F1 can be cold started using just battery power, thanks to an inverter that can convert the DC power of the battery onto AC power for some essential equipment. Battery switch, set it to on. This action connected the battery to the battery bus. On the top row of the warning panel several lights illuminate, Alt 1 and Alt 2. The generators 1 and 2 are not producing power, because the jet engine is not active yet, TR1 and TR2. The transformers 1 and 2, which normally convert the AC power from the generators into DC power, are not active, since the generators are out. SEC. The inverter is supplying power to the emergency AC system. The battery is the only source that supplies the electrical system at the moment. It has an endurance of at least 13 minutes if the electrical pump is off. Warning horn switch, enable. The horn goes active to confirm that it is. You can adjust your seat height by click and hold on the highlighted switch. Left click raises the seat, right click lowers it. It is very handy when landing, as a high angle of attack can impede your view of the runway. The aircraft has a 5-liter liquid oxygen tank. This liquid is converted to gas and adapted to a breathable temperature. The oxygen is then directed to the ejection seat oxygen unit, where it is distributed to a regulator from where it is delivered to the pilot. The seat also includes an emergency 0.4-liter oxygen tank, to be used on emergencies and during pilot ejection. The aircraft oxygen tank supply has a duration of 4 to 11.5 hours, while the emergency tank has a duration of 7 minutes in case of ejection. both oxygen warning lights, Reg 02, for oxygen regulator failure, and 5-minute 02, for 5 minutes of oxygen remaining, should be off. Check the lamp bulbs by press and hold the T button on the warning panel. The 5-minute 02 light should illuminate, along with all the other lamps. Now press and hold the T02 button to test the Reg 02 light and the oxygen warning sound. Next, let's test the oxygen quantity gauge on the oxygen panel at the right console. Press and hold its test button. The quantity gauge should be on the green. Release the test button. On the left side of the ejection seat is the oxygen selector. Confirm it is on its normal position, aft. On the oxygen panel the blinker should be active and a letter N should be visible. On this position the oxygen regulator supplies the pilot with a varying mixture of air and oxygen. Starting at 33,000 feet, the regulator provides pure oxygen. Now, move the oxygen selector forward to its 100% position, middle, with a right click on it. On the right panel, the N should have been replaced by a white square, denoting that the system is now providing 100% oxygen irrespective of the altitude. Finally, move the oxygen selector again with a right click to its forward emergency position. Now, on the right panel, the white square should have been replaced by a red square, denoting that the system is now using oxygen from both the main and the emergency tanks. Leave the oxygen selector at normal, with 2 left clicks, to finish the oxygen check. We will now review the cabin checks that are performed on the real aircraft. They are not really needed on DCS, but they do provide a lot of insight into many of the aircraft systems. Some of these checks require full electric power, rather than just the battery alone, so we will ask our ground crew to connect a ground power unit. Press the / key to bring up the DCS communications menu. Good, now select F8, ground crew. F2, ground electric power. F1, on.
Chief, turn
Press
on the ground power.
spacebar once you hear the ground power unit functioning. You can check
Copy.
it visually to your left.
Ground power is now on.
As it is starting to get dark, let's adjust out cockpit lighting. First, set the dimmer lever to its night position. Its top concentric knob allows adjustment of panels and lights, including the warnings panel, armament panel, fuel panel, air brakes, limitations, fire, emergency regulation, afterburner, and nose wheel steering. The ultraviolet knob adjusts the intensity of the instruments panel UV lamps. The P2B large knob adjusts the red flood lights of the instrument panel. Its top knob adjusts the integral lighting of the instruments panel. The bank large knob adjusts the red flood lights of the lateral consoles. Its top knob adjusts the integral lighting of the consoles. On the clock side, there is a 3-position switch. Its forward position illuminates the miscellaneous instruments, standby compass, clock, accelerometer, and the angle of attack tape. Its aft position illuminates only the angle of attack tape. The mid position is off. For this mission, switch it to its forward position. The left knob on the bottom of the clock is the adjustment for the map white light. The right knob adjusts the lighting intensity of the miscellaneous instruments. The highlighted knob adjusts the lighting intensity of the angle of attack indicator. Its effect can't be seen when the engine isn't running. The highlighted knob adjusts the autopilot light's brightness. Its effect can't be seen when the engine isn't running. Now that we have our cabin illuminated, let's perform the cabin checks following a sweep, starting from our far left and ending on our far right. Jpt Emergency Regulator switch, check it's on auto. This switch, when set to stop, disables the regulator that keeps the jet pipe temperature within normal parameters. Set it to stop if the Jpt temperatures become abnormal during the flight. Switching the Jpt regulator back on is prohibited when RPM is over 8,300. Afterburner main cock switch, confirm it is at open, with its guard down. It allows fuel onto the afterburner section of the engine. Close this valve, F position, only in the event of a fire on the afterburner. Uhf Red Radio, set as required for the mission. The Trap 137B, also known as the Red Radio, is an UHF radio unit. It can operate in the frequency range from 225 to 399.975 MHz. The frequency can only be chosen from 20 preset channels, as it has no manual tuning capabilities. The highlighted knob is the radio's function selector. It allows selecting the operation mode of the radio. AR is off, M is on, and F1 and H are unused. Set it to M to turn on the radio. Set the test selection switch alternatively to R, and then to E+A2. The radio will do a receiver. Next, select the transmit power, 5 or 25 watts. For the squelch switch, applies a static noise filter to the received audio. Enable it. The switch positions are not marked, but it is very noticeable on which position the noise filter is active. As an exercise, let's tune the radio to the UHF frequency of the air traffic controller of our current airbase, 252.25 MHz, which is currently stored on the preset number 8 of this radio. Good, the radio is now tuned to the UHF frequency of our local ATC, ready to communicate. Slat flap lever should be full forward, the retracted position, or in the same position as the flaps currently are. You can use the F2 external view to confirm their position. Throttle lever, check the following on your hoters. Throttle lever at stop position, rearmost. Air brake switch, confirm they are retracted. Combat flap lever, check they are retracted. In-flight relight control, confirm it is on its aft position, off. When this control is switched on, it is self-held on this position for 30 seconds, at the same time the starting solenoid valve is opened, and the ignition plugs are energized. The in-flight engine relight procedure will be seen in more detail on a separate training mission. High lift device selector switch. Confirm it is off. The Mirage F1 high lift devices are basically the wing's leading slats and the trailing edge flaps. The off position disables the leading edge slats. Normal allows for both slats and flaps to be operated. Rentry sec hours is for emergency use and retracts both flaps and slats. Radio selector unit, set. This panel allows you to set the volume of the various audio sources, as well as selecting the radio we will use for transmitting. The Mirage F1 has two independent audio mixing amplifiers. Amplifier 2 is powered by the battery system, while Amplifier 1 is powered by the main DC system. For this mission, push on the green radio knob to select it, and turn it to increase its volume. Master arm switch, check it's on its off position and with its cover guard down. This switch is duplicated by the undercarriage safety switch, located on the left main wheel well, which prohibits firing weapons when the undercarriage is down. LP main cock switch, confirm it is on its closed, unguarded, position. This is a fuel valve that opens or closes the fuel supply from the feeder tanks to both the engine and its afterburner. The LP stands for low pressure, as the feeder tank is pressurized to only 1.3 to 1.9 psi, while the remaining internal tanks use 6.4 to 7.0 psi and the external tanks use 12.3 to 12.9 psi. Left and right-hand LP pump switches, check they are off. The Mirage F1 fuel system comprises a right and a left systems, which are normally isolated from each other by a crossfeed valve. The LP pumps are powered by the AC electric system, and are installed at the bottom of each feeder tank, left and right. The remaining fuel tanks of the aircraft, both internal and external, transfer their fuel onto the feeder tanks by means of bleed air pressure. Ignition ventilation selector, set to one of the two ignition positions, left or mid. The Mirage engine has two separate ignition coils, and any one of them can ignite the fuel-air mixture to start the engine. To have them wear evenly, on the real Mirage a start log is kept, that allows you to select the least used coil for the next engine start. On DCS either coil is fine. The right position of the switch is used to ventilate the engine in case of a failed start, motoring it without ignition nor fuel intake. VHF, UHF, green radio, set as required for the mission. The TRAP 136, also known as the green radio, is a dual-band VHF, UHF radio unit. It can operate in the frequency ranges from 118 to 143.975 MHz, for VHF, and from 225 to 399.975 MHz, for UHF. It is equipped with a transmit receiver and a guard receiver. The main frequency can be entered manually, or selected from 20 preset channels or from the guard frequency. The guard frequency can be monitored at the same time as the main frequency. The highlighted knob is the radio's function selector. It allows selecting the operation mode of the radio. AR is off, PAL allows to use only the main frequency, PAL plus G allows to use the main frequency and listen to the guard receiver, and F1 and H are unused. Set it to PAL or PAL plus G to turn on the radio. Set the test selection switch alternatively to R, and then to E plus A2. The radio will do a receiver or a transmitter test respectively, during which the red test light illuminates and an audio tone is heard. 1. Next, select the transmit power, 5 or 25 watts. For this, squelch switch applies a static noise filter to the received audio. Enable it. The switch positions are not marked, but it is very noticeable on which position the noise filter is active. As an exercise, let's tune the radio to the VHF frequency of the air traffic controller of our current airbase, 122 MHz. First, set the frequency source using the highlighted knob, which selects between manual frequency input, preset channel or guard frequency. Set it to M, for manual. Use the frequency rotors to input 1220 and 00. Good, the radio is now tuned to the VHF frequency of our local air traffic controller, ready to communicate. Emergency regulation switch, check it's off, guarded. The Mirage engine is a SNECMA ATAR 9K50, single-spool turbojet. Its normal operation is controlled by an automatic main regulation system, which regulates the fuel supply, the RPM, the stop sequence, the temperature, the overspeed device and the bleed valves. In the event that the main regulation system fails, the pilot can enable, with this switch, an emergency regulation system which can provide fuel supply to the engine within a reduced flight envelope. This causes a reduction in engine thrust, the afterburner cannot be used, and the throttle handling by the pilot must be smoother as its response time is longer. Emergency regulation light, click on it to test its bulb. Landing light control, check it's off. This switch has 3 positions, off, back, taxi, mid, and land, forward. It can be operated only when the nose undercarriage is down. Brake chute control, should be forward, lever tip up, marks aligned. Moving the control lever aft opens the chute, and returning it forward drops the chute. It can be deployed. Canopy embrittle control, confirm it's on its aft position. The embrittlement control is used to manually activate a pyrotechnical system which cracks the plexiglass of the canopy, to offer a low resistance to pilot escape during an emergency. Undercarriage control lever, confirm it's down, and its safety lever is set, to avoid accidental retraction. On the Mirage, the undercarriage retraction is powered by the hydraulic system 1. Yaw and anti-slip switch, check it's at its anti-slip position. The yaw channel of the flight control system handles the aircraft's rudder. It has two modes of operation, electro-hydraulic control, which is the default, and mechanical control as a backup. The rudder's FCS also has an automatic anti-slip mode that compensates any side slip in stabilized flight. This 3-position switch, off, anti-slip, and yaw, allows you to deactivate the anti-slip mode and the electro-hydraulic mode separately. Pitch switch, confirm it's on its pitch position. The pitch channel of the flight control system handles the aircraft elevators, and has the same 2 modes of operation as the rudder. This switch allows the pilot to deactivate the pitch's electro-hydraulic mode. Inverter Selector switch, at auto, guarded. In the pitch channel of the FCS, an element called Inverter plays an important role. The Inverter function is to limit the pitch sensitivity of the aircraft in certain situations. It has 3 modes, high sensitivity, low sensitivity and automatic. In normal operation in auto mode, it adjusts the control stick sensitivity as a function of altitude and airspeed. Stick uncouple switch, off, guarded. This switch allows the pilot to cancel the autopilot action over the flight stick, used only upon autopilot malfunction. Selective weapon jettison button, check it's guarded. External stores can be jettisoned through push buttons on the frontal panel. An emergency jettison that drops all payloads is available, but stations can also be selected through a switch. Outer missiles are not jettisoned, being launched not armed instead. Vertical speed indicator, check it's at 0. Its indication covers ± 6,000 feet per minute. Its readings are accurate in the absence of side slip. RPM indicator, check it's 0. Graduated in RPM, it has 2 pointers, the shorter one indicates thousands of RPM, the long one indicates hundreds. Engine lights, tested. Press each of the 3 engine indicator lights, INJ, afterburner injection active, FON, afterburner on, and ADF, Alamajdan's La Fowli, the device that allows directly moving the throttle from any dry position to any afterburner position. Check alert lights. Test their lamp bulbs by click and hold the mouse on each light. Engine and afterburner fire detection lights. Fire detector loops are located on the engine and afterburner fuselage bays. Pressing this light causes the warning horn to sound and also checks the detection circuits for continuity. Undercarriage not down, press to check. This light illuminates if any of the undercarriage legs is not extended, the engine is at less than 8,100 RPM and the speed is below 215 knots. Air brake deployed, press to check. This light illuminates whenever the 2 fuselage air brakes are deployed. Limit, limb, and warning horn. Press the light to test its bulb and horn. This light illuminates if the undercarriage is down at speeds over 240 knots, or if the flaps are deployed at speeds in excess of 225 knots for full flaps, or 300 knots for half flaps. It will also illuminate and sound if the combat high-lift devices exceeds their limits, 470 knots or 1.1 Mach for the slats, or 335 knots or 0.85 Mach for the combat flaps. Configuration indicator, test its light bulbs by press and holding its test button, T. This test also illuminates the combat flaps light, V, CBT, and the nose wheel steering, DIRIG, light, which are outside the indicator proper. The DIRIG light is already lit because the nose wheel steering is not yet fully powered, as the engine isn't started yet. Release the button after checking all lights. Shock cone position indicator, confirm it's measuring 1.27. The Mirage F1 incorporates a pair of moving shock cones on the engine air intakes, to provide maximum efficiency as the Mach speed varies during the flight. Their position is adjusted automatically, but can also be adjusted manually if needed. Mach airspeed indicator should be at 0. This instrument simultaneously displays calibrates airspeed, in knots, on its outer dial, and Mach number on its inner dial. Use the knob to set its reference index to any desired speed. Slaved altimeter, red flag visible. The slaved altimeter reports the barometric altitude computed by the Air Data Computer, ADC. The altitude is displayed by a pointer which makes one revolution every 1,000 feet, and a 4-drum counter which indicates the tens, hundreds, thousands and tenth of thousands feet, up to 75,000 feet. In case of failure of the ADC, a stripped red flag will mask out the drum counter. Use the knob to enter the correct barometric pressure on the smaller 4-digit counter, from 930 to 1070 millibars. Standby altimeter, set. Of 3-pointer type, it has a black and white hatched sector which is visible at altitudes below 10,000 feet, and invisible at altitudes over 26,000. Use the knob to enter the correct barometric pressure on the smaller 4-digit counter, from 870 to 1050 millibars. Clock, wound and set. This is a chronometer type clock, including a small pointer which indicates elapsed time on a dial, from 0 to 15 minutes. The highlighted button is the chronometer start-stop reset control, while its underside right knob is the clock wind and time set control. Standby magnetic compass, heading check. This is a magnetic compass with a graduated circular dial indicating magnetic heading. Accelerometer, G-meter, reset and confirm it displays a value of 1. This linear instrument has 3 pointers, one of which indicates the current instantaneous acceleration value, while the other 2 indicate the maximum positive and negative values attained. We will now check the sight controls that are on the front panel, but prior we will briefly turn on the sight, by flicking the highlighted switch to on, marche, with a right click. Sight. The sight has 2 controls on its top, set as follows. Lighting selector switch, set to N, normal. This switch controls the HUD image lamps. Its positions are: aft, A, all HUD reticles are off. Mid, N, normal operation, and N appears at the base of the switch. Forward, S, for emergency operation, and S appears in a red background at the base of the lever. This position is used when one reticle goes out, burnt bulb. Intensity selector switch, set to auto. This switch controls the HUD brightness modes. Auto, forward, the brightness set by the pilot varies automatically according to external luminosity to maintain a constant contrast. Man, aft, manual mode. The brightness of the reticles is regulated, with a fixed value, by the pilot through brightness rheostats at the bottom of the sight, from left to right. Fixed reticles, heading and altitude. Moving and target reticles. Attitude reticle, pitch ladder. Sight system test button, not simulated. Spherical indicator, set its NP selector switch to N. The P position enables the ball to be fixed at the South Pole, in case of failure. The spherical indicator displays to the pilot the following information: pitch and roll of the aircraft, current heading, gyroscope magnetic or magnetic, deviation from a Tarkan or VOR, ILS course. A roll index at the bottom gives the bank angle. A side slip ball is provided at the base of the instrument. When used in conjunction with the VOR, ILS or Tarkan, 2 pointers, vertical and horizontal, and a to from flag, appear and give. In the VOR or Tarkan mode, deviation from the present beacon bearing, in relation to the selected approach bearing. In the ILS mode, deviation from the glide path and localizer beams. An ND light flashes as the aircraft passes over marker beacons. Standby horizon, check its caged, flag visible. This backup instrument is independent of the gyroscopic system, displaying pitch and roll information to the pilot. Navigation indicator, set its mode selector to AR, off. This instrument can display navigation bearings from different radio sources, the Tarkan, the VOR and the radar, selected via its mode selector. Mode VT is for VOR or Tarkan, Mode TE is for radar, Mode TT is for radar and Tarkan. For Tarkan in TR mode, an additional vector function can be used. This function essentially allows the pilot to get bearing information to any point relative to a Tarkan station. We will learn more about this on a future Tarkan navigation mission. Fuel controls, set as follows. Fuel remaining indicator, input the fuel quantity, in liters, that the crew loaded into the aircraft. For our current mission, enter 4,240 liters, corresponding to full internal fuel. You may click on the flight stick base to hide or unhide it. Be careful not to click on the eject loop. Fuel transfer sequence selector switch, as required. For this mission set it to clean, LIS, as we don't have external fuel tanks. The aircraft has a total of 9 internal fuel tanks, and capability for carrying up to 3 external tanks. This switch allows variations in the center of gravity to be minimized, depending on if you are carrying external fuel or not. Emergency fuel transfer switch, set to off. Normally, the fuel flows from one tank to the next in sequence by bleed air pressure. This switch allows gravity transfer from the aft lateral tanks onto the feeder tanks, for use on an emergency. Crossfeed switch, set to off. Normally, the left and right fuel systems are kept separate, but the crossfeed valve allows interconnection of the 2 feeder tanks. Never use this if one of the tanks is leaking, as you will lose fuel from the intact side too. Dual fuel gauge, test the gauge by pressing its test button. The gauge measures the internal fuel, in liters, of both fuel systems, using 2 pointers. Pressing the test button causes the pointers to turn counterclockwise, as long as it's pressed. Upon release the pointers return to their initial position. Feeder tank or fuselage selector switch, switch to fuselage, then feeder tanks. This switch selects if the gauges display the fuel quantity in the feeder tanks only, or in the whole fuselage. Fuel transfer indicator, lights tested. This indicator provides a graphic representation of the status of the different fuel tanks of the Mirage F1. As each tank gets depleted, its corresponding light will illuminate. Note that the 2 feeder tanks are not represented. Press its button to test the light bulbs. Nose wheel steering high sensitivity button, check it's depressed. This switch determines if the steering is on high sensitivity, 45 degrees of steering, or not, 7 degrees of steering. The button is released after taking off, when there is no weight on the front wheel. Shock cone manual control switch, confirm it's at neutral position. This switch is used to adjust the cone's position manually, in the event of failure of its automatic control. Anti-skid switch, on, guarded. The braking system is equipped with an anti-skid device that can be disabled with this switch. Hydraulic pressure selector, set to 1 servos 2. This switch sets the dual hydraulic pressure gauge to visualize either the pressure in circuits 1 and 2, or the pressure on the ancillary and brake subsystems. The Mirage F1 has 2 separate main hydraulic circuits, to provide a certain redundancy in the hydraulic supply of some elements. Each circuit is pressurized by a pump powered by the engine and counts with a hydraulic deposit. The hydraulic system feeds the control surfaces, the Arthur system, the wheel brakes, the landing gear, the high lift devices, the shock cones, the air brakes, and the nose wheel steering. We will now adjust the radar controls that are on the front panel and right console, but prior we will briefly set the radar to standby, by flicking the highlighted switch to its mid position, with a right click. Radar indicator scope, check the following items. 1. Polaroid screen, adjust as required. The radar screen has an optical outer surface consisting of 2 Polaroid glass filters, which allows adjusting the luminosity of the screen in function of the external luminosity. Its adjustment control is located on the border of the screen. For day operations set it to its mid position, for night operations move the adjustments fully counterclockwise. 2. Intensity and remanence, reduce as needed. The LUM knob adjusts the luminosity of the echoes appearing on the screen. The RWD knob adjusts the remanence of the traces on the CRT screen. Radar Indicator Scope Control Unit, set knobs as desired. The Scope Control Unit is located on the right console. Its 5 thumb wheels afford the following adjustments. EC, brightness adjustment of the scope lights. AL, strobe brightness adjustment. MQ, adjusts the brightness of the distance markers. LH, adjusts the brightness of the aircraft silhouette on the screen, and on interception mode it also adjusts the luminosity of the velocity marker. CH, adjusts the vertical position of the horizon reference line on the screen. Emergency undercarriage handle, check it's in and folded back. This handle allows deployment of the undercarriage by gravity, when there is no hydraulic pressure. Its first position opens the doors, the second drops the gear down. Alternator switches Alt1 and Alt2, confirm they are set to on. These switches connects the alternators to the AC system. On the warning panel the Alt1 and Alt2 yellow lights will illuminate, since the alternators depend on the jet engine running to generate electric power, so they are not operative yet. Inverter Selector, check it's on its mid position, auto. This switch enables the emergency AC system to be supplied by the alternators or the DC system, through the static inverter. It has 2 steady positions, conv and auto, and a rearm spring-loaded position. When the alternators are not producing AC power, the emergency AC system 1 is switched to the inverter. To indicate this, the sec light goes on. After the engine starts, the alternators cut in when they reach their frequency and voltage thresholds, at approximately 2800 engine RPM. At this point, the inverter selector is set to rearm, switching the emergency AC system back to AC system 1. The sec light goes out. Position light switch, set as required. The switch has 3 positions, up, bright, mid, off, and down, dim. For this mission, set them to dim. On formation light switch, set as required. The switch has the same 3 positions as the navigation lights. For this mission, set them to dim. Canopy seal valve lever, set to inflate, gonflage, forward, once you have fully closed the canopy. The canopy seal is deflated merely by unlocking the canopy. Standby horizon switch, check it's off, aft. This switch provides electric power to the standby horizon indicator. Electro pump switch, check it's off. This switch energizes the hydraulic system's electro pump. This pump activates automatically when the pressure of hydraulic circuit 1 is too low. Warning horn switch, off. The warning horn is used to call attention to particularly important failures and limitations. Pitot probe heater switch, off. This switch enables anti-icing heating, not only for both pitot probes, but also for the static air data inlets S1 and S2. S3 and S4 are not heated. Radar warning receiver switch, check it's off. The RWR provides the pilot with an omnidirectional alert, visual and aural, an indication on the direction and the type of threat, when the aircraft is illuminated by a tracking or fire control radar. Searchlight switch, check it's off. The searchlight is a fixed lateral light fitted on the left side of the fuselage, adjustable on the ground only. It illuminates forward, on a bearing of 22 to 42 degrees to port. The light is operated by turning this switch to on, and then press the control stick searchlight button to illuminate. It can be activated only in flight, for a maximum duration of 15 minutes continuous. Armament Control Panel. 1. Sight Selector Switch, check its off, array. This is a 3-position switch, aft is off, its mid position is on, march A, and its forward position places the sight in approach mode, with velocity vector. 2. Radar Selector Switch, confirm it's off, array sec hours. This is a 3-position switch, its mid position sets the radar in standby, where it is ready to operate but does not emit. Its forward position, radar emis, places the radar in full operational mode. 3. Selection push buttons, check that all are unselected. Exterior G, left wingtip IR missile. Exterior D, right wingtip IR missile. MG FUS, left wing or fuselage mounted Matra R530 missile. MD, right wing Matra R530 missile. Can A, guns air to air. Can S roke, guns or rockets air to ground. Bomb voil, wing bombs. Bomb FUS, fuselage bombs. 4. Single scanning switch, as required. This switch sets the radar scan to 4 lines or single line mode. 5. Norm, DEN selector, as required. Use norm for firing the R530 or S530 missiles, and to DEN for the S530 when there is too much altitude difference with the target. Gyroscope System Selector, check it's off, array. Selects the source of the heading information coming from the main gyroscopic unit, gyromagnetic, purely magnetic or emergency. It can also turn off the system. If the system is turned off for more than 15 seconds, turning it back on will start the erection process anew. When not on the ground, this process has to be performed in leveled flight. It takes roughly 35 seconds to obtain an approximate alignment and 1 minute to be performed fully. Emergency Gyromagnetic Compass Selector, check it's off, array. The emergency gyroscope only provides heading information and is also slave to the magnetic field of the Earth through another magnetometer. Tarkan, confirm it's off. The Tarkan navigation aid is turned off by rotating its mode knob to off. We will learn its use on a future training mission. VOR, ILS, check it's off, array. Air conditioning. Cabin and equipment air conditioning makes use of bleed air from the engine. The hot air is circulated through a pre-cooler which lowers its temperature, and then a branch pipe supplies air to the following subsystems. Windshield demisting, radar pressurization, canopy seal inflation. Last, a master valve provides air to the cabin and the equipment bay. A solenoid valve regulates the mixture of hot and cold air, thus regulating the cabin temperature. Master valve control switch, off. Setting the master valve to on, enables cabin pressurization once the canopy seal is inflated. The pressurization schedule is: from 0 to 6,500 feet, there is no pressurization. From 6,500 to 18,000 feet, the cabin pressure is equal to 6,500 feet altitude. Above 18,000 feet, the cabin pressure is higher than outside pressure by 300 millibars. Emergency cold switch, off. If the air conditioning system becomes jammed in the full hot position, and if the manual actuation of the temperature control is ineffective, move this switch to on, a closing signal is fed to the regulating solenoid valve. Cabin temperature control knob, auto. When this knob is on its top 12 o'clock position, the solenoid valve operates automatically. When set towards 6 o'clock it operates fully manual. Auto manual selector, set to auto. When set to auto, the equipment bay temperature is regulated automatically. When set to manual, the temperature is adjusted by the pilot using the hot-cold, Chord-Freud switch. Ram air switch, off, guarded. This switch controls a ram air inlet in the left side of the nose cone, which ensures cabin ventilation with fresh air in case of malfunction of the air conditioning system. Demist switch, off, aft. When the demist switch is set to its forward position, the demisting valve of the air conditioning system opens and allows a direct flow of hot air onto the front windshield panels. We have reached the end of the cabin check section of the cold start procedure, so we will ask our ground crew to disconnect the ground power unit in order to perform the rest of the procedure with just battery power. Press the / key to bring up the DCS communications menu. Good, now select F8, ground crew. F2, ground electric power. F2, off. Press spacebar once the ground power unit is no longer functioning. You can check it visually to your left. Press F12 to clear the menu.
Ground power is now off.
Starting is made on battery, with canopy closed or partially open, and parking brake set, but before proceeding, we will contact air traffic control to request startup clearance. Make sure the green radio is on and set to the manual frequency of 122.0 MHz, and the green knob is pushed in on the audio panel. Next, press the / key to bring up the DCS communications menu. OK, now select F5, ATC, F1, H3 airbase. F3, request startup. Press spacebar once ATC has granted clearance. Press F12 to clear the menu. Ignition and ventilation selector, switch to alternate ignition plug, left or center switch positions, to evenly wear the ignition plugs upon starting. The right position is used to ventilate the engine in case of a failed start, motoring it without ignition nor fuel intake. LP main fuel cock, switch to open, towards the left, and then guard it. This is the main fuel valve that opens the fuel supply from the feeder tanks to both the engine and its afterburner. Left and right LP pumps, set to on, left. Lift the starter button guard, with a left click. This action pushes to on the starting LP pump. This fuel pump is used only during the jet engine startup, supplying additional fuel pressure for the start. The BP, low fuel pressure, warning light should go out. Once the BP light goes out, immediately depress the starter button for 1 second, with a left click. Never exceed 2 seconds with the button depressed. At 300 to 600 RPM, move throttle to idle, by moving the lever forward and then back. The low oil pressure light should be on until RPM reaches 2000. Watch the RPM and jet pipe temperature indicators and check that the engine accelerates normally. The Alt 1 and 2 lights should go out at 26 to 2800 RPM, as the alternators are now online. Idle RPM should stabilize close to 2900. The Hydro 1 and 2 lights should go out as the engine reaches idle. Flick the inverter switch to its reset position, with a left click. The sec light goes out. On the environmental panel, master valve control switch, set to on. This enables both the cockpit and the avionics bay cooling. Temperature control, set to auto. The environmental system will keep a comfortable temperature automatically. On the heading control panel, the Mirage F1 carries a main gyroscopic system and an emergency gyroscope that feed information to other systems such as the sight, the spherical indicator, the autopilot and the navigation indicator. Gyroscope reference system selector, set to GM, gyroscope, magnetic. Emergency gyromagnetic compass selector, set to on, so it will work as a backup for the main gyroscopic system. The gyroscopes will begin their alignment process, which takes about 2 minutes, during which you can continue this procedure. The CAP light will go out once the gyros are aligned. On the navigation panels, our aircraft is equipped with both a Tarkan and a VOR ILS system. The heading, distance and flight slope information generated by these systems is used by the autopilot, the navigation indicator and the spherical indicator navigation pointers. The route commutation unit can be used to select the source of the radio navigation input to the indicator pointers. VOR and ILS, set to on. For training purposes, let's tune it to the nearby, at Tanf Airbase VOR, its frequency is 114.0 MHz. Tarkan, set to air and select station. Iraq has no ground Tarkan stations, but for this training mission, we will tune our tanker's Tarkan which is orbiting nearby. Its channel is 054 X-ray. On the bearing selector box, select VOR and ILS, or TAC. For this mission, set it to VOR. On the armament control panel, radar selector, set to standby. This will activate the radar on standby mode. Sight, HUD, set to normal, mid position. This is a 3-position switch. Aft is off, its mid position is on, March A, and its forward position places the sight in approach mode, with velocity vector. Next, let's enable all the electric-powered systems. Standby horizon switch, set to on, to power up the backup horizon indicator. Hydraulics electric pump, set to on, the Hydro S light goes out. Warning horn switch, check it's still on. Probe heat switch, set to on. The pitot probes and some of the static air data inlets will be heated to prevent ice buildup. The ANEMO light goes out. Radar detector, RWR, switch, set to on. Searchlight switch, as required. The searchlight is a fixed lateral light fitted on the left side of the fuselage. It illuminates forward on a bearing of 22 to 42 degrees to port. The light is operated with the control stick searchlight button. Finally, let's enable the last items on the front instruments panel. Navigation indicator, set to VT or as desired. Standby horizon, uncage. By turning the mouse scroll wheel over the knob to center the index, this will uncage the standby horizon. Radar detector warning panel, switch to test momentarily. Shock cone push button, depress, for automatic operation of the engine inlet cones. Flight control servos, reset by pressing this knob. The remaining warning lights should clear after this reset. There still remains one warning light, P-cab. It alerts us that the cabin is not yet pressurized. Push the lock control forward. To lock the canopy, the warning light should go off. If the canopy is still partially open, click on its handles to fully close it, prior to operating the lock control. Now that the canopy is locked, inflate its seal by pushing the canopy seal valve lever forward, to its inflate, gonflage, position. Congratulations, you have completed the full cold start procedure, including the cabin checks. It seems kind of long because of all the explanations, but this has allowed you to know just about every flight system of the aircraft. Well done. Press spacebar to exit the mission.